Okay, so we're on the second half of 6.5. We have the rest of the wagon wheel warm-up. Front wheel has 4, that's this. Wagon wheels could cover a distance of 15 miles per day. So what we need to do is convert the feet, the circumference, into miles, or the 15 miles into feet. Makes much more sense to convert larger into smaller, or smaller into larger, because that means no decimals, rather than the other way around. And so we're going to go ahead and convert 15 miles into feet, which comes to 15 miles over 1 day times 5,260 feet in 1 mile times 12 inches in a foot means that the wagon could cover 946,800 inches in 1 day. Okay, and so then all you need to do is divide that number by the circumferences, the circumference of the front and the circumference of the back. Pretty straightforward. A wheel rotates r times per minute, right? For how much rotates in seconds, and again, you're going to do a conversion factor for that. So moving on into the rest of the lesson. So in part 2, we are talking about the moving shadow some more. And now we're not going to spend as long playing with cosine as we did with sine. You'll notice that we went really quickly through it with the other day. And that's pretty much all she wrote for cosine as far as our changes. So we already know that sine is vertical movement, or y, and cosine is horizontal movement. And now we want to go ahead and expand our SOHCAHTOA definition for cosine into the unit circle world. And so we have our circle on our things, and we're going to use r, x, and y. So recall that we know that r, which is the radius, is this. So this one's y and this one's x. So r is equal to x squared plus y squared, and take the square root of that. And so that's that. We know what r is. We know sine is opposite over hypotenuse, so y over r. And cosine is adjacent over hypotenuse, so x over r. And we're going to use these definitions forever. So it's important to know these. You need to have these committed to memory. I will not be giving them to you during quizzes or tests or anything else like that, and your quiz is coming right up. So just keep those things in mind. We've got r, sine, cosine, everything's there. So make sure you've got those down. If you need to create this picture during the exam, that would be perfectly appropriate. Just what helps me is remembering cosine is side-to-side movement. It's the shadow on the ground, so it's x because that's side-to-side movement. Y, which is the position of the rider above the ground, that's vertical movement. And so sine is the vertical movement. Sine goes with y, cosine goes with x. Hopefully that clears everything up for you. And we're moving to the problems at hand. So what now we're being asked to do is find the values of sine and cosine on these circles. So you've already done this in 6.3, I believe. Homework, it might have been 6.4. No, 6.3's homework where we did this with sine. And tonight on your homework, you're going to be doing it with cosine, but now we're going to do it for both. So what we need to do first is figure out what r is. We know that r is equal to the square root of 1/2 squared plus the square root of 3 over 2 quantity squared. And so we have these two things. We continue, and that leads to 1 over 4 for 1/2 squared plus the square root of 3 squared is 3, the square root, then 2 squared is 4, which we figured out a minute ago, which is equal to the square root of 1, which is equal to 1. So r is 1. Now I have r. I already have x and y in my point right there. So for sine of theta, it's equal to y, the square root of 3 over 2 over 1. And I'm not going to write the 1 down because dividing by 1 leaves everything the same. Then we have cosine of theta, which is equal to x over r. And again, r is 1. If r was anything else, it'd be part of that, and we would have messed with things. So that's what we're doing. Go ahead and try this. Pause the video and try this one on your own. make sure you pause because you know you're going to come back and have the answer be right there in your face. All right, so again, we found r. We squared this. We got 2 over 4. Squared that. We got 2 over 4. And again, r is 1. So sine is the y coordinate and cosine is the x coordinate. So when r is 1, sine is just x, sine is just y, and cosine is just x, which is pretty cool. So that's what that is. And then you've got your homework tonight, which is more of the same, except for that this time r is not always going to be 1. And it also is only looking for cosine. But if you want to practice doing sine, go for it. This is however, I must warn you, these are the exact same problems we're on 6-3, so you'll be doing the exact same work again. All they did was recycle them and put them in 6-5. So they're the same problems, but this time they're asking for cosine. So you've already done some of this work. If you want to still do your own work, that's perfectly acceptable. Otherwise, go for it. So you got those two, and then you've got these 3, 5, 6, and 7. Don't forget about 7. It's easy to do so. And of course, yesterday's homework was more intense. So there's that. Scrolling down some more, just to quickly talk about, I don't know if I have it. I'm scrolling up. The homework from the day before, which was quite intense, actually, asking you for missing sides. Now, the first 4 problems are 45, 45, 90 triangles. I hope you noticed that. The next 4 problems were 30, 60, 90 triangles. I hope you noticed that. There's an absolute pattern. We want you to get so that these are automatic. You don't have to do any work. So you're doing the Pythagorean theorem to find out your missing sides. And once you have that, it shouldn't take, you're supposed to go faster, is the hope. And then 21 and 22 are taking which are not numbered the same on yours, but are taking the other problems and applying them to a square and an equilateral triangle, which is where everything came from. Then we asked you weird questions about pi. It's important that you get very comfortable with pi as a number and a quantity, not as this strange variable you don't know, and everything should go fine from there. So good luck, and we'll see you soon.